Okay, today we are talking density. So we have a couple of problems here, and we're first going to solve them using the density equation. So you find a chunk of metal, you're not sure what it's made of, but you can measure its mass, you have its volume. We're going to have to determine what that is made of, what type of material, in this case metal, is it made of. So I'm going to begin with my density equation. Density equals mass over volume. Then as I read through the problem, I have to recognize my units. Grams, as it says, is mass. I have to recognize grams, kilograms, milligrams. Those are units of mass. Milliliters, as it says, is a unit of volume. Milliliters, centimeters cubed, liters, those are all units of volume. Remember, my unit for density is grams per centimeter cubed or grams per milliliter. So I always have to be working in grams, centimeters cubed, or grams and milliliters. And both of my units are already there, so I'm in good shape. I can just take those values and plug them in. So density equals my mass, which is 25.65 grams, divided by my volume, which is 9.5 milliliters. So when I complete that operation, what happened here? When I complete that operation, then density equals 2.7 grams per milliliter. I would then go to my reference section, look at my density reference sheet, and see that aluminum has a density of 2.7. So that chunk of metal was aluminum. My second problem presents me with the exact same thing. I'm finding density, so I'm going to use my density equation. Density equals mass divided by volume. But now I have a little bit more complicated values to work with. I see that I'm given my mass, but my mass is in it's in kilograms. And as I said up here earlier, I have to get my mass into grams. And then it gives me a length, a width, and a height, 0.5 meters, 0.75 meters, and 1 meter. That makes it really difficult for me to work with because I'm not given a volume. So I just have to figure out what that volume is. I guess it's really not that difficult. So first thing I'm going to do is convert my 45 kilograms into grams. And for that, I'm going to use dimensional analysis. So I have 45 kilograms. I want to get to grams. As I know, there are 1,000 grams in 1 kilogram. So I'm going to have to flip that, or just leave it the way that it is. Don't flip it, plug it in. 1 kilogram on the bottom, so my units cancel. 1,000 grams up top. And I have 45,000 grams. All right, so now I have to deal with my volume. And again, I need centimeters cubed. If you know the conversion factor for meters cubed to centimeters cubed, you can multiply these things out and get meters cubed and then convert. But we don't have that conversion factor memorized. So I'm going to convert these lengths into centimeters first. So again, I'm going to use dimensional analysis for that. So I'll do that over here. 0.5 meters. I want to get to centimeters. 1 meter is equal to 100 centimeters. So this is 50 centimeters. And I'm not going to do all the work for all of them, but I'd have 50 centimeters times 75 centimeters times 100 centimeters. And that is equal to 375,000. My unit is centimeters cubed. Each one of these is a unit of centimeters, so that gives me centimeters cubed. Now I have my mass right over here. I have my volume right over here, and now I can plug those in. So density equals 40, that's 4, 45,000 divided by 375,000. So density equals 0.12 grams per centimeter cubed. And when I look that up in my reference, that's balsa wood. So that is using density to identify a material or a substance.